So guys, good evening and welcome back. And today we're going to extend our thought process to percentage. Now today is going to be a very special session. Why? Because in this session we're going to take up a very specific type of question sets. Now these concepts that we'll be discussing today are very important. Why are they very important? Why? Because this concept is vastly and widely used in data interpretation also. Today what we're going to do is we're going to go through the concept of application of percentage in Venn diagram questions, right? So today we're going to do Venn diagram based questions, and in this session we're going to understand in which questions do we apply the concept of Venn diagram, which questions application of the Venn diagram logic is not required, how you can apply the logic of Venn diagrams, and in which way you can get the answer. So that will be the agenda of the day, and this is what I have it in store for you guys. But before we start, I have decided that I will continue the habit of having a thought of the class for every class. So this is what came to my mind. For the last 2 3 days, I've been struggling with the thought that how come such a famous actor, such a person who has almost achieved everything in his life, has to give up his life and has to, has to suicide. So I am not able to understand. I mean, what is the reason behind that? Giving it a lot of thought. So the only thing that comes to my mind these days is that today is the age of competition, and people judge, and we have a fear of being judged. We as youngsters, we as youth, we as students, we as strugglers, we as faculties, every person in the society, whomsoever is a part of the so-called society, is judged. And this fear of judgment, kya kahenge log, and fear of being rejected by society is a big fear, right? So this is the thought process. So this came into my mind that if you let the world decide whether you are a failure, so if you let people around you decide for you that whether you should be called a failure or a success, then my dear friends, you will never succeed in life. So if you keep it into mind that people are after you and it is the person's or the society's approval which is required to make you happy, to define your success, then my dear friends, you will never be able to succeed in life. Success is not only money, fame, name, being recognized by people. That's all surface happiness, I would say. Success is something that you believe in. Success is something that brings a smile on your face. So this is my thought. So my initials. So with this thought, we're going to start with today's session. And as I told you in the beginning itself, we're going to talk about the questions based on Venn diagrams. So today we were going to understand that what are the questions on Venn diagrams, how do we solve them, and the most important thing is that in which questions in data interpretation we can use this logic of Venn diagrams, in which questions we cannot. So let's have a look at these two questions. So we'll start with having a look at these two questions. Now, can you tell me, looking at these two questions, as to which questions you would be applying the concept of Venn diagrams and in which question you won't? Let's read them out first and then let's get started. The first question says, in an examination, 82% students pass in English, 75% pass in mathematics, and 70% passed in both the papers. If 52 students failed in both the subjects, what is the total number of students? This is the first question. The second question is, in an examination, 15% students secured first division, 20% students secured second division, and 35% students secured the third division. What will be the total number of students if 120 students failed? So as you can, hi Devendra, how are you? As you can see that in both the questions, there is a breakup of a larger value and they are breaking up it in chunks. So I will tell you that the first question we will be having Venn diagrams. In the second question, there is no need to have a Venn diagram. Why? When we use Venn diagrams, we use them solely because there has to be an overlap somewhere. There has to be an overlap somewhere. So if there is no overlap of data, of numbers, of values, then Venn diagram is not required. But yes, if there is an overlap of values, then the data will be, then the Venn diagrams will be used. Let's have a look at the first question and then try and understand how we can apply the concept of Venn diagrams over here, right? So because we have got two specific categories. One category is students who pass in English, and the second category is students who passed in mathematics, right? So we are representing one circle for those who pass in English and the other circle for those who pass in mathematics, right? This rectangular box is the total students. This is the universal set, the universe, right? So the question says in an examination, 82% students passed in English. So if 82% students passed in English, this would mean that the blue circle that you can see, which is representing the students who passed in English. So this blue circle, the entire blue circle comprises of 82% of the students, right? Similarly, the number of students passed in maths is 75%, not the number, but the percentage, right? 75. So this black colored circle that you see is representing 75% of the students who have passed in mathematics. And it also says 70% passed in both the papers. Now the story is that some of them must have passed in English but not maths. Some of them must have passed in maths but not English, and some of them must have passed in both the examinations, right? So if I talk this intersection part, this common area is for those who have passed in English and maths both. And the question itself says 70% students have passed in both English and maths. So what do we understand from all this? So we please try and understand, if 82 is the entire circle, if 82 is the entire circle, of which 70% is this much, which is comprising of students who pass in English as well as maths, how much of it is remaining outside? 12%. Now this 12% is those number of students or those percentage of students who've passed in English alone. Similarly, 75% is the total. 75% is the total number of people passing in maths. 70% passing in maths and English both. So the remaining 5% would be passing in maths alone or maths only. So this is the thought. So if I say English only, 12% of the students passed. If I say maths only, 5% of the students passed. If I say only one subject, it will be 12 plus 5, 17% students passed. So if I ask you how many students passed exactly in one subject, it will be this much plus this much, 17%. So if I say failed in one subject exactly, so that will be 83%. Is that the case? Tell me. Is it or not? We'll look at this a little later, right? But let us see whether 83 is the correct answer or not. It is not the correct answer. Now please pay attention. Both is 70%. So when we add them up, what do we get? 70 plus 5 is 75. 75 and 12 is 87%. So now this 87% of the students either passed in English only, or passed in maths only, or passed in English and maths both. So how many students? The remaining 13% is the population which is outside these two circles, which means that they haven't passed in any of the subjects. So 13% students failed in both. 83 is not the correct answer. I was trying to confuse you. That is why I've circled the answer, right? I knew you haven't understood this. We're going back to that, so don't worry, right? I have deliberately said because I want you to take this bait so that you fall into this, right? So now this much is clear. So if I ask you how many pass in only one subject, you will say sir 17%. I say how many pass in both these subjects, you will say sir 70%. And I ask you how many failed in exactly one subject. How many failed in exactly one subject? So now what do you do? Now the failed in exactly one subject is also 17%. Why? Because these are the ones who have passed in English but failed in maths. Now these are the ones who've passed in maths but failed in English. So this is gonna be the same. So one big mistake that you guys do is subtract 17 from 100 and let it go on to the failed number of students. This is to be avoided. Right? Give me a quick yes, Devendra, if you understood this now. Others also give me a quick yes in case you've understood this now. So we can move on to the next question. Give me a quick yes. Okay. Let's move on to the next question. Now, this question will be similar to what you just saw in the previous question. So let's try have yes, these are interesting, and these are the questions that form the basis of any data interpretation set also. So if you understand these, you'll be able to solve data interpretation very, very easily. In an examination, 36% students failed in Hindi, 47% failed in English. If 22%, thank you, if 22% failed in both these subjects, what is the total number of pass percentage students in both these subjects? So I'm not asking how many passed in one subject, I'm asking how many passed in both these subjects. So again, we'll make a big box. Let's have two circles. Now, let's take this circle for Hindi and let's take this circle for English. Now we can use them for those who failed, right? There is no need to convert from failure to success. If you always try to convert failure to success, you will always end up being Sushant Singh Rajput. No need to convert failure to success all the times. Bring success to failure. Accept failure and then improve, right? So you're not trying to convert anything. Failure is past. Future is a new sheet, a new slate. I can always start it afresh, right? So don't mull over what past happened. Okay, in an examination, 36 students. So this is 36%. Now these students failed in Hindi. 47% failed in English and 22% failed in both. So if 22 is over here, 36 is the entire circle, what remains is 14% over here. If 47 is over here, 22 is over here, what remains is 25% over here, right? So if I say failed in one subject only, so that will be 14 and 25, 39%. If I also ask pass in exactly one subject, this is again will be 39%, right? If I say failed in both, which is already given to us as 22%, right? Now if I ask you pass in both, so pass in both will be this one, whatever is outside the failure, right? These will be passed in both. So now let us please add them up, right? 14 and 22 is 36. 36 and 25 is how much? 61. So these circles put together will make how much? 61 percentage. So whatever left over here will be 39%. So how many students passed in both the examination? That will be 39%, right? So you'll have to understand what to include and what to exclude in such questions. Very good, Ayush. I hope you got this correct. So can we move on to the next question, right? In this session, we're going to focus on very specific these questions only so that you get a good understanding of the entire topic, right? Now, let's move on to this question. It's a very interesting question. Over here, you have to first read it and tell me whether you will be applying Venn diagrams here or not. If yes, then how? We'll have a look at that, right? So please go through the question and tell me whether you'll be applying Venn diagrams here or not. Let's have a look. Now, in a boys' school, the boys play three sports. All the boys play three sports, either cricket or football and basketball. There are 1200 boys in all, out of which 60% play cricket, 50% play football, and 45% play basketball, right? 55% of the total boys play at least two sports. 55% of the students play at least two sports. 18% play cricket and football both. 18% play cricket and football both. 20% play football and basketball both, and 23% play cricket and basketball both. So how are you going to start with this? Obviously, there is an overlap in the values. Some of them are playing two sports and some of them might be playing three sports also. So yes, we will be needing a Venn diagram somewhat like this. So already designed a Venn diagram in front of you. Now we're going to solve this, right? So we got three sports: cricket, football, and basketball. So we'll take this blue circle for cricket, the yellow circle for basketball, for football, and the pink or red, I don't know what color is it on your screen. I'll take it as say reddish pink to be politically correct, right? And the basketball as the circle below, pinkish red, whatever it is, right? You're not taking the outer box. Why? Because each and every student plays at least one sport for sure. This question says in a boys' school, the boys play three sports. There is nothing mentioned as to how many students don't play anything. So these circles, three of them put together, will comprise of the entire 100%. Is that the case? Let's have a look. Okay, just give me a sec. Yeah, this is it, right? So total is how many? Total is 1200. Let's write it down over here. There are 1200 boys and out of 60% play cricket. So cricket is how much? 60%, right? 50% play football. 50% is how much? Football. 45% play basketball. Okay. 45% play basketball. 55% of the total boys play at least two sport. So 55% play at least two sports. So what do you mean by this? At least two sports, which means that this portion, let us call this as A. Let us call this as B, let us call this as C, and let us call this as X. Right? So X is the percentage representing those students who are playing cricket and football and basketball, all three sports. X plus A. X plus A would be what? X plus A would be cricket and football. I'm repeating, X plus A will be cricket and football. X plus B will be football and basketball. X plus C would be those students playing cricket and basketball both. A alone, I'm repeating, A alone. A alone would be cricket and football only, not basketball. Exactly two sports. B alone would be football and basketball only, not the third sport. C alone would be cricket and basketball only, not the third sport. Got it? So what the question is saying is A plus B plus C plus X. This is 55%. Why? Because 55% of the boys play at least two sports. At least means two or more. 18% play cricket and football both. 18% play cricket and football both. So X plus A is equal to 18. Got it? 20% play football and basketball both. So football and basketball is X plus B. This is how much? 20%, right? And 23% play cricket and basketball. Let us see. So cricket and basketball will be X plus C. This is how much? 23%. So if we add up on the left hand and the right hand side, what do we get? We get 3X plus A plus B plus C, and this should be equal to 40, 50 and 161%. Got it? This is 61%. So this is equation number 1 and this is equation number 2. So if we subtract 1 from 2, if we subtract 1 from 2, A will go away, B will go away, C will go away. So 2 minus 1 will give me how much? Will give me 2x, and that will be equal to 6. 61 minus 55 will be 6. So x is 3%. X is how much percent? 3%. So we can start filling the blanks over here. This is 3%. Now x plus a was 18, so a alone will be how much? 15%. X plus b was 20, so b alone would be 17%. X plus c was 23, so c alone would be 20%. Got it? So if I ask how many percent of the boys play only cricket and football, 15%. How many boys playing cricket and football? 18%. Why? We are including those also who are playing all the three sports. And same goes for football and basketball, basketball and cricket, and so on and so forth. Now this entire blue circle is 60%, of which 20 and 15 is 35. 35 and 3 is 38. So we'll be left with the remaining 22%. So 60 minus the sum of these three will give me this. Right? So what is this? These are the number of students playing only cricket. They are playing only cricket. Now let's come on to this one. Football is how much? 50. So 15 plus 17 and 17 and 3 is 20. 20 and 15 is 35. So the remaining would be 15%. Right? And this one is 45. So 20 and 20 is 40, and the balance is 5%. Now if at all, now let's quickly use this. This was 3%. This was 15. This was 15. This was 17. 5, 20, 22. 5, 20 and 22. We did it little cricket, football and the basketball. Now we have to check what comes over here, whether there is any students who are not playing anything or we are left with nothing. So we'll have to subtract the sum of all these values from 100, right? So 22 plus 5 is 27, 27 and 15 is 42. 42 and 3 is 45, 45 and 15 is 60, 60 and 20 is 80, 80 and 17 is 97. So we left with 3% over here, right? So those who are playing none of these sports, 3%. Exactly 1 will be 22 plus 5 plus 15, 42%. Exactly two sports will be 15 plus 17 plus 20, that will be 32, and 15, 52%. All three would be again 3%, right? So 52 plus 42 is how much? 96, 94, 94 and 3 makes it 100. So this is the exact distribution of the entire values. So if I ask you the total number of students being 1200, how many play all the three sports? So 3% of this would be 36, and equally you can distribute the values accordingly, right? Now if I ask you how many play exactly, how many play not more than two sports, how many play not more than two sports, so you'll have to exactly all three you have to exclude. I say how many play two or more sports, so you have to take two and all three. So you'll say 55% of students play two or more sports. If I say how many students play something or the other, so bhaiya 97% of the students play something or the other, because these are the 3% who don't play anything. So there could be multiple varieties of questions built around this concept. This is a very in thing. Caselets is what we call them at most of the times. So you can come across this question for sure in one of the examinations, to make sure that you prepare for such questions very, very well. The purpose for having for behind me having this kind of question over here is that to give you a glimpse of how percentages as a thing can be used in Venn diagrams, and where you have to use Venn diagrams, where not. The next coming series on percentage, you're going to stretch this concept a little longer. So I'm going to take up certain unique DI questions also in percentage, right? So give you a comprehensive understanding of what percentage and its application lies. So we're going to do a few more sessions on the basic concepts in percentage, and then we're going to talk about the applications of percentages across various topics, and then you will get a rounded approach to what percentage is. So that's the entire stuff. Three, I had already written it down somewhere, so that is what it comes down to, right? So I hope you enjoyed the session. Don't forget to like, share, subscribe, comment, tell it to your friends, and tomorrow onwards, please bring your friends along, and we'll be giving free gifts also. So tomorrow onwards, again we'll be going back to the basics where we started. We'll be giving away a 6-month test series for free for all those who participate well. So not one, not two, but many of the test series will be as giveaways tomorrow. So please participate and ask your friends to join in, and that will be a good thing. And don't forget to share, write a comment, subscribe, whatever you can, and stay calm. And don't forget this thought process, that if you let others judge you, if you let others decide whether you are a successful or a failure person, then, my dear friends, you will never be successful in life. So look inwards and only then decide where you're going in life. Like, don't give the control to people, especially those who don't know you, especially those who are not loved ones, to judge you. You should never give them the right to judge you. This is what I would say. Stay strong, stay focused, stay healthy. Bye bye. I'm gonna catch you tomorrow. 5:30 p.m. is the new timing, so don't forget. Till then, bye bye. God bless you.